Okay, so what we're looking at today is linking Venn diagrams, probability and probability trees. So we're going to start off with something nice and easy. So the set of numbers 1 to 10. So the set of numbers 1 to 10 we can split into square numbers. And we will very imaginatively call that set S. So our set S is going to be 1 squared, which is 1, 2 squared, which is 4, 3 squared, which is 9. So the rest of the numbers 1 to 10 would be not square numbers. Square numbers, and that is a much bigger set. We call that S dashed, so that little dashed is not, and so the set that is not S, so not square numbers, is going to be 2, 3, 5, 6, 7, 8, and 10. So, if we're looking at this from the point of view of a tree diagram, then our first section is going to have to be whether or not a number is square. So, on our tree diagram, we would have square, or we could write S, and we would have not square. So that would be square with a little dashed. So the probability that a number is square out of the numbers 1 to 10 is going to be 3 out of 10. And the probability that a number is not square is going to be 7 out of 10. On a Venn diagram, we've got our little set S. So inside S, we've got 1, 4, and 9. And in the bit that is not S, we've got everything else. So we've got 2, 3, 4's already there, 5, 6, 7, 8, 9's already there, 10. So we've dealt with our first bit. Now, what we can do there is then potentially look at even numbers. So, even numbers are a set that we are possibly unimaginatively going to call E. So, even numbers are E, and our even numbers are 2, 4, 6, 8, 10. And we don't call the odd numbers, we call them not even. So those ones that are not even, we would call, so not even numbers, we are going to call E dashed, because the little dashed means not, and that will give us 1, 3, 5, 7, 9. So, if we work on the principle of our tree diagram, we're going to look at first off our square numbers. So square numbers, probability of picking a square number is 3 out of 10. Then we're looking at even numbers. So, probability that it is even, but we're only dealing with the ones that are square. So we are dealing with the probability that it is even given that it is square. And we've got, if we look, we've got one number in our square numbers that's also in our evens. So on a Venn diagram, we end up with a set that is even, So the probability that it is even, given that it is square, basically tells us that we are looking at the bits that are just in the square section. So the probability that it is even, given that it is square, is just that number 4. So that is 1 out of 3 numbers. The probability that it is not even, so the probability that it is not even, given it is square, is going to be this 1 or 9. So that's going to be 2 out of 3. So, as with a normal tree diagram, if you want the probability that you've got square and even, so the probability that you have square and even is going to be this times by this. So square and even is going to be 1 out of 10, which is what we'd expect because it is that bit in the middle that is square and is even. The other option that we had is square and not even. If we multiply these two together, we get the bits that are square and are not even, so just that 1 and 9. So the probability that we are square and not even is going to be 2 out of 10, and we don't have to cancel it down because it's probability. So if we were dealing with the whole set, we've got that bit in the middle, square and even is 1 out of 10, square and not even is 2 out of 10. So if we're dealing with the not square bit, so everything that isn't currently coloured in pink. So not square and even would be the probability that it is even given that it is not squared. So even and not squared. The not pink bits are the not squared bits, and we've got 1, 2, 3, 4 that are even and not squared out of 1, 2, 3, 4, 5, 6, 7. So the probability that it is even and not squared, so probability that it's even given that it's not squared is 4 out of 7. So the probability that it is not squared and is even, if we multiply those two together, as normal for tree diagrams, is 4 out of 10. So if we're looking at it being out of everything, we're looking at 4 out of 10. The other option that we've got is that it is not even. So even dashed. Because we're already on this branch, we already know it's not square. So we are looking at the probability that it is not even given that it is not squared. So we know that we've got 7 that are not squared. Of those, 3 of them are also not even. So we are looking at the remaining 3 out of 7 as not even, given we already know it's not square. So if we start from the original set, we're going all the way along. So we've got this one multiplied by this one. So if we consider everything, then we've got the probability that it is not squared and not even is going to be 3 out of 10, which makes sense because if we go back to considering everything, we've got 3 of those out of 10. So, bits that you need for Venn diagrams. You need to be able to write the probability of something happening. So in this case, probability that it's square is the pink bit, so 3 out of 10. You need to know the probability that it is even given that it's square, so looking at the ones in the pink bit that are even. And you need to know the probability of and, so this happening and this happening. So in this case, that's first off, out of everything, just looking at the pink bit, then just looking at the even bit. So multiplying this and this together, which gives you the probability of square and even. One thing that is useful to notice is, as you've experienced with probability at secondary in GCSE, is that these two numbers will add together to give 1, because the probability that it's square and it's not square, or it's not square, is all of the available opportunities. These two here will also add to 1, because at this point we're only looking at squared things, so things are either even or not even. These two here will also add to 1, because if we're looking at the not square things, it'll either be even or not even. And all of these options together at the end will also add to 1, because the options that we're looking at is either square and even, which is the 4, square and not even, which is the 1 and 9, not square and even, so 2, 6, 8, 10, or not square and not even, which is 3, 5, 7. So each split is always going to add together to give you 1. Hopefully that helps.